Good day, my viewers. You are welcome to Corrosive Online Tutorials, where complex topics are made simple for you to understand. In today's video, we'll be looking at oxidation and reduction reactions. I repeat myself, oxidation and reduction reactions. Now, what is oxidation and reduction reaction? Now, oxidation and reduction reactions always occur simultaneously in any given chemical equation. You cannot have one without the other, and you cannot have reduction without oxidation. So both of them always occur side by side. They occur simultaneously. Now, what is oxidation? Now, I will draw a table to define oxidation. Thereafter, I will now give you some examples, practical examples that will drive my points, okay, to the destination. Now, the first one I have oxidation. The second one here I have reduction. So let me define the first one in terms of electron loss or gain. Number one, oxidation is the loss of electron. So oxidation is the loss of electron. It could be one, so let me put X to bracket it. While reduction is the gain of electrons. The gain of electrons. Reduction is the gain of electrons. So whatever is lost here is gain here. That is why you always have the two occurring simultaneously. Number two, I can define both of them in terms of oxidation number. Okay, so oxidation is an increase in oxidation number. Is an increase in oxidation number. Oxidation is an increase in oxidation number, while reduction is a decrease. Is a decrease in oxidation number. Is a decrease in oxidation number. Now, when I will give you example, I will expatiate on the meaning of oxidation number, okay? Now, number three, we can say that oxidation is the addition of oxygen. The addition of oxygen, while reduction is the remover of oxygen. Reduction is the remover of oxygen. Then number four, I can say oxidation is the remover of hydrogen. Oxidation is the removal of hydrogen, while reduction is the addition of hydrogen. The addition of hydrogen. So when hydrogen is added to a substance or a compound, that process is reduction. So this table will differentiate the difference between oxidation and reduction. And in some textbook, you will see that it is called redox reaction. Redox. Red is for reduction, ox is for oxidation. So we have redox reaction. It's a combination of both, okay, to form it. Now, let me give a typical example. So just copy this down and let's look at typical example so that we can drive our points home. So let's look at the various examples of these reactions. Let's look at the various examples of this reaction, okay? Now, the first one, I want to use sodium and the reaction between sodium and chlorine to form sodium chloride. Now, look at this reaction critically. Sodium is unstable, chlorine is unstable, but sodium chloride is stable. This one is stable, this one is unstable, this one is unstable. So when a substance is unstable, that substance has the tendency to be reactive. It has the tendency to go into reaction. So these two substances are very reactive because they are unstable. Now, why are these two substances unstable? Why? Because if you look at the electronic configuration of sodium, is 281, and that of chlorine is 287. So chlorine has 17 electrons in its atom, while sodium has 11 electrons in its atom. Now, according to this duplet and the octet rule, is that for an atom to attain stability, it must have 2 electrons in its first shell, 8 in the second shell, 8 in the third shell, and so on. So if you look at sodium now, it has 1 in its outermost shell instead of 8. Now, this one makes sodium to not to be stable. So it's dangling, it's not stable. Chlorine has 7, okay, instead of 8. Now, because of this 7, chlorine is not stable. He wants to attain stability by gaining 1 electron, while sodium wants to attain stability by losing 1 electron. So it is easy for sodium to lose the electron to chlorine. Now, when the electron is lost from sodium to chlorine, sodium becomes 2,8 and chlorine becomes 2,8,8, which is this compound 4. So this becomes plus 1, this becomes minus 1. So it is these two charge, like charge repel. Unlike charge, we attract. So there's a force of attraction between these two charges. And that force of attraction is what keeps this bond together. And this bond is ionic bond. Okay? So this is stable. Now, before stability, what happens? Electron is transferred from sodium to chlorine. Now, look at this species. Which of them is undergoing oxidation and which of them is undergoing reduction? Remember, I told you oxidation is the loss of electron, while reduction is the gain of electron. So if you look at sodium and chlorine, which of them is losing electron? Of course, sodium. So sodium is undergoing oxidation. So that process is oxidation. Why is losing electron? While chlorine is undergoing what? Reduction. Is undergoing reduction because it's gaining an electron there. So this reaction is a typical example of a redox reaction. Redox, reduction, oxidation, reaction occurring simultaneously. Now, let me give you another example again. Look at iron 2 chloride. Iron 2 chloride plus chlorine to give you FeCl3. Now, this is iron 2 going to iron 3. Okay? So, this is iron 2 plus 2. This is iron 3 plus 3. And remember, we said that oxidation is an increase in oxidation number. So, what is oxidation number? It is the combining power of an atom. Oxidation number is the combining power. Okay, and for a free element, the oxidation number is 0. And a free element is an element in an uncombined state. The element is not combining with any other element. So when you are free, it is 0. Like chlorine, the oxidation number of chlorine is 0, while it is in uncombined state. But the oxidation number of iron here is plus 2. While that of chlorine here you can see minus. Okay, so but iron is what? plus 2. So iron is going from plus 2 to plus 3. And we said that oxidation is an increase in oxidation number. So there is an increase here. It's going from plus 2 to plus 3. So I can say that iron is undergoing oxidation. So this is oxidation reaction. This is oxidation reaction. Then why chlorine is undergoing reduction? Chlorine is undergoing reduction. Why reduction? Because number one, we said reduction is a decrease in oxidation number. Chlorine is 0 here, but here is minus 1. So it's going from 0 to minus 1. Chlorine is going from 0 to where? To minus 1. And 0 is higher than minus 1 because minus 1 is already on the negative side. So there is a decrease in oxidation number, and that is reduction. And that is what? Reduction. I hope that is well understood. So oxidation reduction reaction, they always occur simultaneously. Also, if you look at this reaction also between zinc plus copper sulfate to give you zinc sulfate plus copper. Now, if you look at this reaction, the oxidation number of a free element I told you is 0. Here, that of copper is plus 2. You can see copper is plus 2. This is copper 2 tetraoxosulfate 6. Now, which of them is undergoing oxidation? Which of them is undergoing reduction? So look at the oxidation number. Zinc here is 0, and zinc here becomes plus 2 because this is zinc, okay, tetraoxosulfate 6. Now copper becomes 0 oxidation number because it's a free element. So zinc is going from 0 to plus 2. From 0 to plus 2 is experiencing an increase in oxidation number. So that process is called oxidation. Then copper is going from plus 2 to 0, decrease. So this is reduction. It's going from plus 2 to 0. So this is what? Reduction. Now we also have what we call oxidizing agents. Oxidizing agents and reducing agents. We have oxidizing agent and reducing agents. Of course, you know the work of an agent. If you want to rent a house, what do? You contact an agent who will facilitate the process of you getting the house. So that is what exactly the work of an oxidizing agent. Now, oxidation is the loss of electron. Now, there must be a substance or a species that will be willing to accept that electron loss. The substance that will accept the electron is the oxidizing agent. That agent makes it possible for the electron to be lost, because when the electron goes out, something must accept it. Whatever accepts that electron is called the oxidizing agent. So I can say that an oxidizing agent is an electron acceptor. Okay? An oxidizing agent is an electron acceptor. An oxidizing agent is an electron acceptor, while a reducing agent is an electron donor. Why a reducing agent is an electron donor. One is an electron acceptor, one is an electron donor. So I can define an oxidizing agent in terms of these two. Also, I can also define an oxidizing agent, that is, whatever is reduced in this equation is an oxidizing agent. Whatever is reduced is an oxidizing agent, and whatever is increased is a reducing agent. Or you can say that an oxidizing agent brings about a reduction process, while a reducing agent brings about an oxidation process. So if you look at the oxidation process here, this is the word. the reducing agent. ROI, reducing agent. ROA, reducing agent. A reducing agent brings about an oxidation process, while an oxidizing agent brings about a reduction process. Whatever is reduced is an oxidizing agent. Let's see what is reduced. Copper is going from +2 to 0, so copper is reduced. So this is what? Is the what? The oxidizing agent. So number one, an oxidizing agent is an electron acceptor, while a reducing agent is an electron donor. 2, an oxidizing agent brings about a reduction, while a reducing agent brings about oxidation. 3, whatever is reduced in the redox reaction is an oxidizing agent. Okay? Whatever is reduced is what? An oxidizing agent. While whatever is increased in the redox reaction is a what? A reducing agent. Now, in my next video, I will take my time to talk about the balancing of redox equation in acidic medium and in basic medium. Until then, bye for now. But don't forget to share this video and make sure you subscribe to my YouTube channel and share the video. Spread it to everyone that might be interested in this. And as you do so, God will bless you. Thank you, and for now.